Hello everyone, I Dr. Kirti Sahu welcome you all to the video lecture on Calculus of Variation. In this video lecture, we shall see various multiple choice questions probably asked in the various competitive exams such as SET, NET, GATE, University and many more. So let us start with the first question. The extremal of the functional I is equal to satisfying the condition is attained on the curve. These are the four choices given. So here, as we wish to find out the solution of this functional with satisfying the given condition, that is extremal or extremum is required. So we know that if the functional is given, then the extremal of the functional is given by the Euler equation. So we will first look for whether we have to apply directly the Euler equation or its deductions. So for that we need to see this integrand of this integral, right? That is we denoted by capital F. So capital F is nothing but dy by dx whole square plus 12xy, which is involving all the contents, that is x, y and y dash. So we will go for directly the Euler's equation, which is given by del f by del y minus d dx of del f by del y dash equal to 0. Now find out the various terms required in this equation, that is del f by del y and del f by del y dash. So we will find out partial derivative of f, which is nothing but this complete term, right? Y dash square plus 12xy with respect to y as well as y dash. So we will reach to this solution after simplification. Now as this is of the form d2y by dx square is equal to completely a function of independent variable. So just by integrating as many times as the order of differentiation, we get the solution. So order of derivative is 2, so we will just integrate this 2 times with respect to x. We get y is equal to x cube plus ax plus b. Now this involves two arbitrary constants a and b. So by using the given condition, that is when x is 0 y 0 and when x is 1 y 1, we will obtain the values of a and b, which are a is equal to 0 and b is equal to 0. Substituting these two values over here, so we find y is equal to x cube. That's why the correct option is nothing but C. Let us have the next question, that is an extremal of the functional satisfies the Euler equation, which in general. So these are the four choices given. So we know that if the functional involves the first order derivative, then by solving the Euler equation we arrive at the second order linear ordinary differential equation. So here this Euler equation give rise to a second order linear ordinary differential equation. Again, if certain conditions are given, so that should satisfies a given condition and the solution should be a unique solution. Hence it should be a second order linear differential equation and it should give us a unique solution satisfying the given condition. That's why the option number A is the correct option. Let us move to the next question, that is the functional where conditions are given. Again we wish to find out the solution of this functional. So we will go in the way similar to the question number 1. So we will first look for what is this expression, what are the contents of this expression. So it involves independent variable, dependent variable and its first order derivative. That's why we will have the Euler equation. We will directly make use of Euler equation. We will not use the deduction of Euler equations, right? Then as per the requirement, find out the various terms, that is del f by del y and del f by del y dash, and simplify that. You will have again the function of the form, an expression of the form d2y by dx square is equal to function of x completely. So just by integrating twice you will get the solution, that is y is equal to x cube plus 2 plus ax plus b. Again, as this contains arbitrary constants and conditions are given, so just make use of these given conditions, find out the value of arbitrary constants. So that will give us a is equal to minus 1 and b is equal to 0. When we put these values over here, what we shall get? We shall get y is equal to x cube by 2 minus x. Now but we don't find such options over here, so we need to arrange that solution again, right? So we will write 2y is equal to x cube minus 2x. So that is nothing but option number D. That's why the correct choice is the option number D. Let us have the next question. Extremal y is equal to y of x. For this problem, satisfying the differential equation. So here we don't want to find out the extremal, but we want to obtain that differential equation which gives us the extremal. So that is obtained just by solving the Euler equation. Again we will solve the Euler equation. Now see here we have the derivative of so we have Euler equation, right? So just put the contents in the Euler equation. So what we have, del f by del y is nothing but 2y, and del f by del y dash is 2y dash. Substituting this over here and simplifying, so again derivative of y dash will be y double dash. Taking 2 common, 2 will get cancelled out. So we have y minus y double dash, which on rearranging we can be written as y double dash minus y equal to 0. Hence the option number B is the correct one. Okay, let us move to the next question. Extremal of the functional. These are given by the following family of curve. So remember, generally most of the questions which are asked in the calculus of variations are of the evaluation of extremals and the basic concepts. So you should know very well how to get the extremal of the functional, and you should have a practice enough to get the solution quickly, right? So let us see how to get the solution for this. So again we will first observe this functional integrand. So integrand is involving x and the derivative term, so it is independent of y. So in this case the Euler's equation reduces to del f by del y dash is equal to c. So we have seen the 4 cases depending upon the dependency of the function f, right? This we have discussed. The Euler equation is this when if it is f is independent of y. So just find out del f by del y dash. So we'll get 2y dash plus x is equal to c, which on simplification can be again further written as y dash is equal to c1 minus x by 2. Now integrate this, what you shall get? You shall get y is equal to c1x minus x square by 4 plus c2, which is nothing but option number B. So in this way, just merely using the concept of the Euler's equation and its various reductions as well as the various form of the solutions, you can get the answer easily. Let us have the next question. So again here we need to find out the extremal. So extremal is not required, but the differential equation which gives us the extremal is required over here. So again we will write the Euler equation because it involves x, y and y dash. Substituting, simplifying, so you will have such type of equation. So therefore option number A is correct, which on rearranging gives us the solution, right? Now next one, the functional. This has only one extremal, infinitely many extremal, exactly 2 extremal or no extremal. This we wish to find out. So if you look at this integrand of this functional, so it is involving a second order derivative. So first we should know what is the Euler equation for a higher order derivative. So as it is involving second order derivative, so we will write the Euler equation for second order derivative. So that is del f by del y minus d dx of del f by del y dash plus d2 by dx square of del f by del y dash equal to 0. If you wish to know what is the Euler equation for further higher order derivative, just go through the video which I have prepared for the calculus of variation. There you will find the full explanation. So with this, just find out the required terms. Del f by del y is 1, del f by del y dash, no term of y dash, so it's 0. Del f by del y double dash will be nothing but, it will be del f by del y dash will be 1, derivative of this, right? Y double dash is 1. So again if I differentiate this constant term with respect to x, so what we shall get? We get 1 equal to 0, which is not possible, completely absurd. So therefore when this situation arises, it means the functional has no extremal. Hence the option number D is the correct one. Let us have the next question, important question, the solution of Euler-Poisson equation. So remember, Euler equation is also called as a Euler-Poisson equations when it is written for a higher order, a functional involving higher order derivatives. So the solution of Euler-Poisson equations are called as, we know very well, it is nothing but called as extremal. So solution is nothing but the correct option is nothing but B. Here it is by mistake written as a D. The correct option is B. Okay. Now then, solid figure of revolution which for a given surface area has a maximum volume. So this is nothing but the problem of isoperimetric, where a surface area is given and we need to maximize the volume. So such type of problem, this is one of the standard problem which generally we solve in case of calculus of variation. So the answer for this is nothing but the sphere, right? Sphere is that volume, that solid figure of revolution which has a given surface area constant and a maximum volume. Then a plane curve of fixed perimeter and maximum area is, again it is a problem of isoperimetric, where a parameter is given as a fixed means, and it means that this functional corresponding to this perimeter is given as constant, and we need to maximize the area. So functional corresponding to area need to be extremized. So when we will solve this type of questions. It is also solved in the that video lectures. This is also one of the standard example. So the answer for this is nothing but a circle. Then an integral which assumes a definite value for the function of the type. So this is nothing but a definition of function mathematically. So any definite integral which assumes a definite value for the function y equal to y of x is called as a functional. So this is nothing but option number C. Okay. Then next one, the equation is called Hamilton equation, Euler equation, Livolli's equation, or Bessel's equation. So we know that the standard there are various forms for Euler equation which are nothing but del f by del y minus d dx of del f by del y dash equal to 0. This is standard one. Then the another form is this one. So if you observe this carefully, so this can be written in this form. So this is nothing but a Euler form. We have one more equation form for a Euler equation. This is this one. So like this we have three different forms for a Euler equation. So question may be asked on any of these three forms. So the viewers or learners are expected to remember these three forms. So this is a Euler equation. So option number B is the correct one. Then we have the next necessary condition for this to be extremum is, so again instead of writing f as the integrand, here h is written. So the necessary condition for getting the extremum of this integral is nothing but given by Euler equation. So that is del h by del y minus d dx of del h by del y dash equal to 0. That is option number A. Then necessary condition for integral to be stationary. So just like the when we evaluate the maxima minima for function of one variable, we consider the condition for the stationary points. So here also the condition for stationary values can be considered for a functional. So that is given by the variation delta of the I. This is denoted by I. If I denote this by I, then the variation of I is equal to 0. So option B is a correct one. So I hope these set of examples you will find useful. So in the next series of lectures, I will come up with few more important MCQs on various topics, or maybe on the same topic. Thank you all for watching the video. If you feel that this you will find useful, then please do share with your peers, your classmates, or the person of your contact. Thank you all for watching the video.